Concept is kind of building off of the Pythagorean theorem, and that is anytime you have the triangles with all integer sides. So again, the two most common are going to be the 3, 4, 5 and the 5, 12, 13. You are going to see these on standardized tests like SAT or ACT. You are expected to be able to work with them very quickly. Right, but if you see these are called common triples or Pythagorean triples. And what you need to be able to do is you need to be able to manipulate them very quickly without having to rely on the Pythagorean theorem. And the way that this appears is anytime you see something that fits this pattern, you should be able to answer it right away. So here you have a right triangle, 3 blank 5. So what does x have to be? It fits that pattern of 3, 4, 5, so it's directly a 4. Okay? Now, the way that you'll most likely see these applied, or actually let me come back here, the same would be true if you see this triangle. So if that's 5 and this is 13, what does this missing side here have to be? 12. Okay, so that's using the process of the common triples. Okay, but more likely what you're going to see is you're going to see multiples of those. So I've listed multiples of these, but I'm going to kind of show what's involved in it. Okay? And that is, if we looked at this sample problem here, you see 6 and 8 are given. Okay? What you want to look to see is, can you find common factors from the given sides that leave you lengths from those patterns? So is there a common factor between 8 and 6? 2, right? If we remove a 2 from 6, we're left with a 3. If we remove a 2 from 8, we're left with a 4. And then look to see what remains. A 3, 4, does this fit that common triple pattern? Yeah, so it's a 3, 4, 5 with a common multiplier of 2. So 2 times 5 would give you the answer directly of 10. Okay? So if you can do that, it'll save you the time from having to go through and manipulate the equations or calculate the answers. Okay. All right, so let's take a look at these examples. Okay, I'll do the first one and then I'll have you do the other two here really quickly. But if you're looking at this first example here, like I said, 3, 4, 5 and 5, 12, 13, those are going to be the most common ones and the ones that you're most likely going to be expected to know without notes or without your calculator. Okay, and so look to see. The hypotenuse is often a good place to start. Is it possible to remove a common or a factor from this hypotenuse to leave either a 5 from the 3, 4, 5 or a 13 from the 5, 12, 13? What can you remove from 20? 4. So let's test that. Can you remove a common factor of 4 out of 16 as well? Yeah, and that leaves a 4. So does this fit the pattern blank 4, 5? Yeah, it fits that pattern of 3, 4, 5. Therefore, if you take that common multiplier of 4, you get your answer for A, 4 times 3, as 12. Okay? With a very quick mental calculation. Now see if you can answer for B and C very quickly. You should be able to answer them very quickly. So what did you get for B? 40, right? That was very simple. You have 5 times 10, 3 times 10, so there's your multiplier. It fits the pattern of 3 blank 5, so 4 times the multiplier of 10 will give you your solution. Right, and then the final example here. Again, this isn't, the 3, 4, 5 is the easiest one to test for, but here, when you look, 3 or 4 doesn't go into 10. Okay, but again, you just have to test the smallest number. So does 5 go into 10? Yeah, so 5 times 2, there's your multiplier. 12 times 2, so does this fit the pattern? 5, 12, 13 times that common multiplier 2, and your answer is 26. Okay. Questions on those? Definitely look for common triples and the multiples of them when you're working through.